Complex number, DeMoivre theorem. Recall, a complex number is z is equal to x plus yi, and polar form of a complex number is z is equal to r cos theta plus I sine theta. We would like to talk about product and quotient of complex numbers in polar form. So we have theorem, and it says if one number z1 is equal in polar form r cos theta plus I sine theta, since we call it first number, we denote this as subscript 1, and the second number with the subscript 2, r cos theta plus I sine theta with the subscript 2, then the product is given z sub 1 times z2. We multiply r's, r1 times r2, and cos, and we add those ones, theta 1 plus theta 2 plus I sine theta 1 theta 2. And the quotient, division of two numbers, complex numbers in polar form, we divide the r's, and cos we subtract the theta, theta 1 minus theta 2 plus I sine theta 1 theta 2. So how did we get those formulae? We're gonna show you only the first formula. The second one is equivalently done. So the first formula that we have r1 times r2, and we add the theta 1 theta 2, and in sine we add them. We had this formula. So how did we get the formulas? So we're gonna start with left side, multiplying those two. So we have z1 times z2, and we're gonna substitute z1, and we're gonna substitute z2. This is kind of derivation. How did we get this? Just to show you, and that you have an idea how did we get those ones. So we have z1 times z2 is equal to, we multiply, so I have r1 times cos theta 1 plus I sine theta 1. That was my z1. Now I will multiply this times, and I'm gonna substitute r2, z2, r2 times cos theta 2 plus I sine theta 2. Okay, everywhere is multiplication. I treat this big bracket as a multiplication. Multiplication, one bracket, multiplication. So I can rearrange those two put together, r1, r2. So this is equal r1 times r2 times those two brackets, cos theta 1 plus I sine theta 1 times cos theta 2 plus I sine theta 2. Okay, now we're gonna FOIL it, multiply out the brackets. So we have r1 times r2 times, and we are FOILing this out. So we have cos times cos, but the arguments are different, so I need to keep it in this form. Cos theta 1, cos theta 2. Now I'm gonna multiply those two. So we have plus, I will put I in front, cos theta 1 sine theta 2. Then we multiply those two. So we have plus I sine theta 1 cos theta 2, and then we multiply the other two. So we have plus I times I, which is I square, sine theta 1 sine theta 2. And we know from definition of complex number that I square is nothing else but negative 1. So we're gonna take those two put together and factor I from those two. This one is nothing else but negative 1. So let's rearrange them. So we have R1 times R2 times, and in that case I have cos theta 1 cos theta 2. Now we have minus 1 times this, so minus sine theta 1 sine theta 2. I'm gonna keep them together, and then I have those two terms. From those two terms I'm taking I out, so we have plus I'm taking out. What's left? Cos theta 1 sine theta 2 plus sine theta 1 cos theta 2. And now we're gonna apply the formulae that we had some time ago. We're gonna apply those two formulae. If we look closely, cos alpha plus beta is nothing else but cos alpha cos beta minus sine alpha sine beta. That's basically this first part. Can we see? We have cos 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 cos, sine 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 sine. So the first part is cos of those two angles added, theta 1 plus theta 2. And those two is my second formula, because we have cos and sine, and then we have cos. We can rearrange them, or we can write this way. We have cos and sine and cos. So the second formula is sine theta plus, so theta 1 plus theta 2. So if I apply those two formulae, I'm getting R1 times R2, and then we have cos theta 1 plus theta 2, and plus I sine theta 1 plus theta 2. And that's exactly what we have. That's exactly what we have on our first screen in the theorem. If we look, Z1 times Z2 is R1 R2, and then we have cos theta 1 plus theta 2, I sine theta 1 plus theta 2. In the same way we can derive the other one, but we're gonna leave it. The derivation very likely is in the textbook. So we do want to know those two formulae and get used to multiplication of two numbers, complex numbers in polar form. So we multiply R1 and we have cos add the arguments, and we have division, we divide and we subtract the thetas. So we have example 1. Find z times w and z divided by w. Leave your answer in polar form. Z is equal to cos 120 degree plus I sine 120 degree, and w is equal cos 100 degree plus I sine 100 degree. So according to my formula, the multiplication here we go. That's the product, Z1 times Z2. So in that form, in this case, I have Z times W. We have Z times W is equal to R. What is my R? There is no r is like 1 times. We can write 1 times. So r is 1. And r2 on the other one is 1 as well. Otherwise it would have been written. And then we have cos. And we add those two angles. So we have 120 plus 100. Then in the formula we have plus I sine, and we add the angles again. 120 plus 100. We can work this out. This is equal to 1 times 1 is 1. So we can omit this. And now we have cos 120 plus 100 is 220. Plus I sine the same 220 degree. And they ask us live in polar form, so that's the polar form of the product multiplication. Now we're gonna go with the quotient. Here is my quotient. We divide r's and we subtract the angles, and the same form cos, cos, sine, sine. So we have z divided by w is equal to the same r is 1, that was the coefficient right here. And we have cos, and we subtract 120 minus 100 plus I sine 120 minus 100. So this is equal to 1 divided by 1 is 1 times anything is the number. 120 minus 100 is cos 20 plus I sine 20 degree. Let's do B. The same story. Find z times w and z divided by w. And z is equal to 4 cos of 3 pi over 8 plus I sine 3 pi over 8. And w is 2 times cos 9 pi over 16 plus I sine 9 pi over 16. So when we multiply r's, this is my r, and we add the angle. So z times w is equal to, we multiply 4 times 2, and then we have cos, and we add those angles. 3 pi over 8 plus 9 pi over 16. Then we have plus I sine, and we add the angle one more time. 3 pi over 8 plus 9 pi over 16. Okay, we need to find the common denominator. From common denominator for 8 and 16 is 16. So this we need to multiply times 2. Times 2. 16 is already there. The same story here, times 2 times 2. So the product is equal. 4 times 2 is 8 cos. Then we're gonna have 6. 2 times 3 is 6, and plus 9. 6 plus 9 is 15 pi over 16 over the common denominator. And then we have plus I sine, and the same story, 6 plus 9 is 15 pi over 16. We can keep the bracket or not necessarily. That's the product. Now we need to do the quotient, divide them. So z divided by w. We divide the number, the r's, so 4 divided by 2 and then we have cos, and we subtract 3 pi over 8 minus 9 pi over 16 plus I sine, and the same 3 pi over 8 minus 9 pi over 16. So the same common denominator, we need to multiply this times 2. 16 common denominator times 2 times 2. The same story here, times 2 times 2. So we have 4 divided by 2 is 2 times, and we have cos 6 minus 9 is what? Negative 3 pi over 16. Then we have plus I sine 6 minus 9 is negative 3, 16. We can go one step farther. We can use the properties of sine and cosine. We know that cos of minus theta is cos theta, and we know that sine at minus theta is minus sine theta, because this function is even, this function is odd. We always have the minus out for all of them except cosine. Cosine, the minus is equivalent. Okay, so this minus disappeared, and this minus can go in front. So this is equal to 2 times cos 3 pi over 16 minus I sine 3 pi over 16. That's my final answer. This is 16. Then we multiply in polar form. How about if we have example C? We still want to find x times w and x divided by w, but this form is rectangular form. I don't have theta, I don't have cos theta, sine theta. So if we need to multiply them, we just go straight ahead. Z times w, 2 plus 2i times root 3 minus I. We FOIL it. We need to FOIL this. Okay, so this is equal to we have 2 times root 3 is 2 root 3. Then 2 times minus I is minus 2i. Then we have those two. 2 times root 3, 2i is plus 2 root 3i. I multiply numbers with numbers and I put the I. And then we have the last one, which is those two. So we have minus 2, and I times I is I squared. But now we know that I squared is negative 1. So we need to substitute this. So 2 root 3. From those two we can factor I out. So we have plus, I goes out. And it's going to be minus 2 plus 2 root 3. And here we have minus 2 times minus 1. Minus 2 times minus 1 is plus 2, and we're going to put this 2 in front. So this is equal to 2 root 3 plus 2, and this I we can write in the back plus minus 2 plus 2 root 3 I. That's the product, and the division would go the same way. Now we need to find z divided by w. So we have 2 plus 2i divided root 3 minus I. And in that case, to perform this, we're gonna multiply by conjugate with plus, so we can cancel out that stuff. So multiply times root 3 plus I, root 3 plus I. Then we're gonna write this down. Then we're gonna write this down in as a product on top, 2 plus 2i times root 3 plus I, and on the bottom I have a minus b times a plus b. So we can apply that this is a squared, which is root 3 squared, minus second squared I squared. So this is equal to, the top we're gonna FOIL it, so we have 2 root 3 plus 2i plus 2 root 3i plus 2 times I squared all over, and on the top we have square root 3 and square it, square root and square cancel out, we have 3, and I square is -1, so I have minus -1. The same I'm gonna substitute for I square as -1. So this is equal to 2 root 3 plus 2i plus 2 root 3i, and 2 times -1 is -2, all over 3 minus -1 is 4. So we can separate them each separately, 2 root 3 over 4 plus 2i over 4 plus 2 root 3i over 4 minus 2 over 4. And this we can reduce to 2, reduce to 2, reduce. So I'm gonna write this is like 1 over 2. I'm gonna put this 1 over 2 in front. So we have 2 root 3 over 4 minus 1/2. And from those two, we have 1 over 2, so we're gonna factor I. So we have 1 over 2, and here we have plus root 3 over 2, and we take I out. DeMoivre's theorem. So it says that if z is a complex number in polar form, r cos theta plus I sin theta, then the power z to the power n, we take the power of r and we multiply the theta plus I sin n theta, and this holds for any positive integer n greater than equal to 1. So let's see some examples applying the theorem. Write each expression in the standard form a plus bi. So we have 3 times cos 80 degree plus I sin 80 degree to the power 3. So this is my power 3. We are rising to the power 3. That's my n. So we can go that this is n, and here is gonna be multiplied times 3. So this is equal to, by the theorem above, we have r, which is my number here, so it's 3 to the power of 3 times, we have cos, and now my power is 3, so 3 times the angle 80 degree plus I sine 3 times the angle 80 degree. This is my n. Okay, now we need to work this out until we get to the number. 3 to the power 3 is 3 times 3 times 3 is 27, times we have cos 3 times 8 is 240 degree, plus I sine 240 degree. But that's not the end, because they want a standard form a plus bi, or x plus yi. So we need to find the angle. We need to find each angle. We need to find cos 240 degree and sine 240 degree. So let's draw the angle. We know here is 90, here is 180 and 270. So if I keep opening, 240 is somewhere here, 240 degree. So how much farther? 180 to 240. What is this angle, reference angle? Nothing else but 60 degree. 180 plus 60 is 240. So we know that sine and cosine is equivalent to the reference angle up to the sine. Add sugar to coffee. So in this quadrant, only tangent is negative. So sine and cosine are equivalent to sine and cosine of 60 degree, but we need to put minus. So this is equal to we have 27, and now we have from this chart we get that it's negative cosine of 60 degree, and then it's gonna be negative sine, so minus I sine of 60 degree. Now we need to use our chart. We need to use our chart. So cos 60 degree is 1/2 times minus 1/2 minus I times sine 60 degree is √3/2. Then we need to distribute the 27, and we are almost there. So 27 times 1/2, 27 is like 27/1. So this gives me minus 27/2 minus I 27 √3/2. This is 27. So that I can put in the back. So this is equal to minus 27/2 minus 27 √3/2I. Example B. The same, we would like to express this in standard form. So we need to apply the theorem. We need to apply the theorem that to the power n, this is my n is 4. So we need to raise the first r to the power n and then multiply the angle times 4. This is my power. So according to this theorem, this is equal to √2 to the power 4 times cos 4 times my angle pi/16 plus I sine 4 times 5 pi/16. We multiply n times the angle. And now we need to work this out. So over 4 is like 4/1, 4/1. This and 16 cancel out. So this gives me 4. This gives me 4. Okay, So square root to the power 4 is square root times square root times square root. Square root to the power 4 is square root times square root times square root times square root. This is square root of 4, which is 2. Square root of 4, which is 2. 2 times 2 gives me 4. Okay, so we have 4 times cos 5 pi over 4 plus I sine 5 pi over 4. Now we need to work this out, the angle. So 5 pi over 4. Here's my pi. In terms of 4 is 4 over 4. 5 fourths is a little bit farther. Right here is my angle 5 pi over 4. How much farther 4 over 4 to 5 fourths? 1/4. So the reference angle is pi over 4. So we have add sugar to coffee. In this one, only tangent is positive. Both of them are, one more time, negatives. So it's pi over 4. So we have 4 minus cos pi over 4 plus I minus sine pi over 4. Now we need to use our chart for exact values. For exact values, pi over 4 right here, it's root 2 over 2 for both of them. So we have 4 times minus root 2 over 2. This minus can go in front, minus I times root 2 over 2. Now we need to distribute the 4 and treat this as over 1. So we need to distribute those two. So we have minus 4 root 2 over 2 minus, I'm going to put the I to the back. So we have 4 root 2 over 2I. And this root 2 can reduce. This can reduce, this can reduce. So we have negative 2 root 2, negative 2 root 2I. One more thing we would like to talk about is the nth root of a complex number. And we had theorem that if W, or that's my complex number, is given in the polar form r cos, and we call it theta sub 0, plus I sine theta sub 0, and we let n be greater than 2, be any integer. And if W is a non-zero number, then there are nth distinct roots, distinct complex roots of W, given by this formula. Zk is nth root of r cos theta 0 over n plus 2 pi k n plus I sine theta 0 n plus 2 pi k n. That k is from 0 to n minus 1. So we have n distinct roots, and we keep going. First root is 0, then 1, 2, up to n minus 1. You don't need to remember this formula. It will be given on the formula sheet if we will use it. So now we have example that we would like to apply that formula. Find all the complex roots. Leave your answer in polar form. The complex cube roots of 1 minus I. Complex cube roots of 1 minus I. So first we need to write this number in polar form, in this form, r cos theta, and then we can take the complex roots. So first we're gonna write this in polar form. First, we're gonna call it our w 1 minus I in polar form. So we need to find r and theta. We need to find r and theta. So in that case we have 1 and minus 1 right here. We are in the fourth quadrant. 1 minus I. We can connect this to get the r. We know that r squared is equal to x squared plus y squared. So r squared, my x is 1, y squared is negative 1. So r squared is 1 plus 1 is 2. So r is square root of 2. Square root of 2. And now my theta, we need to find this theta, but we can use the reference angle. So tangent of the theta is y over x. So tangent theta, we can go with negative 1 over 1. So theta reference from my chart. Theta reference from my chart, where tangent is 1. That case is negative, but we're going with positive 1 is pi over 4. Pi over 4, or let's go for pi over 4. So now we need to write this angle. This angle is whole 2 pi. 2 pi in terms of 4 is 8/4 pi. So that theta is equal 8 pi over 4 minus that 1/4 pi over 4. So it's 7 pi over 4. Or we can go in degrees. Maybe it would be easier for us to go in degrees. So theta is 360 degree minus 45 degree. So this is equal to 165 degree. And now we can write the polar form. Polar form of 1 minus I is, we know that the polar form is z, or we're gonna call this one w, is r cos theta plus I sine theta. So in that case is square root of 2, and we have cos of, we had 165 . This kind of doesn't make sense, because we had this 360 degree minus 45 gives me 315 degree. I'm sorry, so here it should be 315. That's what we had, 315 degree. So then the polar form, we write it down, is 315 degree plus I sine 315 degree. So now we can apply the formula for those roots. Here we have the formula. we want to find the cube roots. That was the question from the beginning. We need to find the cube roots. Find the cube roots. Cube root. So distinct cube roots. My n has there are n distinct roots of w. So my n is 3 cube roots. N is 3. So my k is gonna be 0, 1, and 2, because we need to find cube roots. So let's apply the formula. We're gonna go z0, it's the first cube root. Now we have the cube of my r, root 2, and then we have cos of my angle, this is theta 315, divided by 3, plus, and k is 0, so this whole going to be 0, plus I sine 315 over 3 plus 0. My theta 0, this is my theta 0, theta 0, theta 0. So then this z0, now let's work out this root 3 over root cube root of root 2 is equal to root 2. We can write that this is 2 to the power 1/2. That's root 2. And this root 3, we can write that this is 1/3. Power of power, we multiply exponent, so this is 2 to 1/6. 2 to the power 1/6 is nothing else but 6 root of 2. Okay, so now we have that this is 6 root of 2 times cos, and we can divide 315. Divide by 3 is 105, plus I sine 105. That's my first root. Now we need to find second. Z is 1 and Z is 2. So Z1 is equal to, I'm going with this formula, so that's the same, we're gonna keep it 6 root of 2 times cos, and now we have the same 315 over 3 plus 2 pi is 360 times k is 1 over 3 and plus we have I sine, and theta 0 is 315 over 3 plus 360 times 1 over 3. We are looking for cube root. C1 is equal 6 root of 2, and this one is 105 cos 105. We can actually add everything together. Plus 360 divided by 3. So this whole number is 225 plus I sine 225. So that's my second root. First one is right here, Z0. This is my second root, and the third root we are applying to this formula as well. Do not get too stressed over those ones. Very unlikely we will be using the nth root formulae. So now we have that the k is 2. Z2 is, this one we had a 6 root of 2 times cos, and we had 315 divided by 3 plus 360 times 2 divided by 3. As before, we had exactly the same. Now we have times 2 right here in those formulae. Then we have plus I sine 315 over 3 plus 360 times 2 divided by 3. So Z2 is equal to 6 root of 2, and this we can get everything from the calculator. 315 divided by 3 is 105. And then we have 360 and times 2, and we divide by 3, and is 240 plus I sine the same story. So we have 105 plus 240. This gives me 345 degree. So we can write this nicely, that Z2 is 6 root of 2, and then we have cos of 345 degree plus I sine 345 degree. So this is the third cube root. Do not get stressed over the cube root formula. We will not be using that formula too much. Okay, we basically substitute to this formula. N is the root's nth. Theta is given from the original equation or from what you find the complex polar form. And k is always from 0 up to 1 less than n. So if n is 3, my k is 0, 1, and 2.